All right, so we are starting lesson 3.3, a system of linear inequalities. And what we're going to do today is solve a system of inequalities by graphing two linear functions and then finding the solution or the overlap of those functions. So just to kind of review or get our minds thinking back into math mode, our bell ringer is to solve the following inequalities. So in order to solve those inequalities, what we're going to do is isolate x in each one. So we can do that now. So you have 5x minus 6 greater than 27. So we have 5x minus 6 plus 6 greater than 27 plus 6. Then you have 5x greater than 27 plus 6, which is 33. Divide both sides by 5, and you get x is greater than 33/5, or 6.6. And number 2, you're going to have two choices to start. You can distribute your -5, or you can divide both sides by -5. Naturally, most students will distribute. So we have -20x minus 5 less than 23. To isolate the x, we're going to add 5 to both sides. And then you have -20x less than 28. Divide both sides by -20. And you have to remember, when you divide an inequality by a negative, the direction changes. And 28 divided by -20, both simplify by 4. So you have -7/5, or -1.4. And then the second thing we're going to do is go back to what we did in lesson 2.8, which was to graph inequalities. So in order to graph an inequality, you are going to start with your y-intercept. So in this case, we're going to start at -1. Then you apply your slope, which is 4. So we go up 4 and over 1. You could also go down 4 and left 1. And then our line is less than or equal to, so it will be solid. And then the y values are less than, so we shade below. That means the solutions for this problem come from both on the line and below the line. In the second part, we have 3y greater than or equal to 6x plus 3. We're going to divide both sides by 3. So that gives y greater than or equal to We've divided by 3 now, so 6 divided by 3 is 2x plus 3 divided by 3, which is 1. So I have y greater than or equal to 2x plus 1. So we plot our y-intercept at positive 1, go up 2 over 1. And then my line, once again, it's greater than and equal to. So the equal to tells me that my line is solid. And greater than tells me that we shade above. So there are a few steps we like to follow when solving a systems of linear inequalities. First, you want to write the equation in slope-intercept form to make it easier to graph. Then you're going to determine if the line is solid or dashed. And then you're going to also determine, do we shade above or below? And then you need to recall that the solutions are included in the shaded regions, and then on the line if the line is solid. What's new in lesson 3-3 is that our systems are now going to have 2 lines instead of 1. So in section 2-8, when we graphed these systems of linear inequalities, we only had a single inequality. In 3-1, when we graphed, we were graphing lines. So once again, we still had 2 lines in a single solution. Now we're going to graph multiple lines and have multiple solutions for each. So here in example 1, we have negative x plus y greater than negative 1. So what we would do is take that equation and rewrite it in y equals mx plus b form. So we're going to add x to both sides. So that would give y greater than x minus 1. Plot our y-intercept of negative 1. And apply your slopes. In this case, my slope is a positive 1. My line is dashed because it's greater than, but not equal to. And then y is greater than, so we shade above. When you shade your first line of the inequality, especially if you're using pencil, you want to do this line really, really light. So you want to know where your shading is, You don't want your shading to be so dark that you can't see the overlap in the next line we're going to draw. So again, this is my first line, my shading is above, and I'm going to keep it rather light when I'm drawing it with a pencil. For your next line, we're going to graph the blue. So once again, we're going to move the x to the other side. So I have y greater than negative x plus 3. Plotting my y-intercept of positive 3. And this is where it's helpful to have, a relatively light shaded first region so you can see where your y-intercept is. My new slope is down 1 and over 1. And then we're going to connect our lines. And then again, this time y is greater than, so y values will be greater than above the second line. So that's this region. But we're looking for the solution of the system of inequalities, which means we're looking for where does the shading of the first line and the shading of the second line overlap. And they overlap in this triangular region right here. It's kind of where the red and the blue make purple. So again, we're looking for their solution or their overlap where the two lines meet. So solutions to the system of inequality are going to come from this shaded region up here. They don't come from on the line because both lines are dashed. Okay, solve each system of inequalities by graphing. You have y less than or equal to negative 2x plus 4. So this is in y equals mx plus b. We're going to plot our y-intercept. Goes down 2 and over 1. My line is solid. And then the y values are less than. So one is y less than, y is less than, below. And then for the blue, we have x greater than negative 3. So there is no y for this problem. So you have an x line alone. You get a vertical line. So we have to go to x being negative 3. And then x being negative 3 goes straight up and down. It is dashed. And then x is greater than negative 3. So when x is greater, that is to the right. So again, their overlap ends up becoming that purple region right in here. So this triangular region is my solutions. And again, it's important to note that the solutions come from the shaded region, and this time they also include the red line, because the red line is less than and equal to. Okay, and then last, we have 6y less than or equal to negative 4x minus 24. So once again, we need to solve for y. So we're going to divide everything by 6. (24) divided by 6 is 4. And then we'll also solve the second equation. So we divide everything by 3. So we'll plot on y-intercepts. So we start at negative 4. Goes down 4 and right 6. Or up 4 and left 6. My line is solid. And y values are less than, so we shade below. Graphing our second line goes through a positive 1. It goes down 2 and over 3. And then my line is solid. Y values are greater than, which tells me we shade above. So when I compare these two lines, they're parallel. One's shaded below, one's shaded above. Since the shadings do not overlap, then this is a no solutions. So again, if the shading doesn't overlap, then there is no solution. Okay, so that sums up the first part of graphing a systems of inequalities. You can go ahead and work on the following problems in your note guide. So after, again, the notes in that packet, it moves on to 3-3, solving systems of inequalities by graphing. You're doing 1 through 9.